In this video, we're going to solve part C of question 9. In this part, we want to find the range of values for theta such that there are two possible positions for m. Alright, so in order to find the range, we have to solve the equations in part B. Okay, let's solve it. So the equation is the square of length A times 1 minus 2k times 2 cosine theta minus 1 minus 2k is 0. Okay. So, because the length of A is non-zero, we can divide both sides by the square of length A. And this will give us 1 minus 2k times 2 cosine theta minus 1 minus 2k is 0. Okay. Well then, this implies that either 1 minus 2k is 0 or 2 times cosine theta 1 minus 2k is 0. So we discuss into two cases. The first case is where 1 minus 2k is 0. 1 minus 2k is 0. That means k is equal to 1/2. But if k is equal to 1/2, then no matter what value theta takes, this equation will always be 0. This means that theta can be any angle from 0 to pi, but not include 0 and pi. In this case, okay, so let's denote the equation part B by star. In this case, the equation star will always be true. It's always true for any theta from 0 to pi. So, this implies that theta, in this case, could be any angle from 0 to pi. Alright. Now, we're gonna look at the second case, case 2. In this case, 2 cosine theta is minus 1 minus 2k is 0. So 2 cosine theta minus 1 minus 2k is 0. So this implies that cosine theta is equal to 1 minus 2k over 2. In this case, in order to find the range for theta, we can first find the range for cosine theta. Okay, to begin with, because k is greater than or equal to 0 and less than or equal to 1, we can multiply -2 to this inequality. After multiplying it, we will get 0 is greater than or equal to -2k, which is less than or equal to -2. In order to let cosine theta pops out in this inequality, we want to add 1 to each term and then divide each term by 2. Okay. So this implies that 1 plus 0 over 2 is greater than or equal to 1 minus 2k over 2, which is greater than or equal to 1 minus 2 over 2. So this implies that the term in the middle is equal to cosine theta. So cosine theta is greater than or equal to -1/2 and less than or equal to 1/2. Alright, So now we have the range for cosine theta. So now let's determine the range for theta. If we look at the graph of cosine theta from 0 to pi, you'll see that there are two intersections of this graph with y equals to 1/2. Here, the blue line here is y equals to 1/2, and y equals to -1/2. So there are exactly two intersections of the graph of cosine with these two horizontal lines. So the black curve here is the graph of y equals to cosine x. Okay, so here the value here is the angle that makes cosine equals to 1/2. So this is equal to pi over 3, and we know that it is pi here and pi over 2 here, and the intersection point here is pi over 3. And in order to make cosine equals to -1/2, x has to be, the theta has to be 2 pi over 3. Because 2 pi over 3 is 120 degree and cosine 120 degree is -1/2. Okay, so these two are the upper and lower limits for the theta. Because from the graph, we can see that if theta lies within this range, then cosine theta will be greater than or equal to -1/2 and less than or equal to 1/2. So, cosine theta being within -1/2 and 1/2 implies that theta must be greater than or equal to pi over 3 and less than or equal to 2 pi over 3. Okay. So this is the range for the value of theta such that there will be two possible positions of m.